All right, this will be our last chapter of the year, and we're going to end things off with probability. All right, so first things first, they introduce us to a tree diagram, and due to timing, I'll let you guys read the question here. A lot of these are going to be real world questions, so let's see how we can deal with these. So the first things first is a tree diagram. And a tree diagram is used to show all of your choices, and some of you have seen this before. So what I like to do first is see what I'm looking at here. So I'm looking at 3 math courses, 2 science courses, and 2 humanitarian courses. So you can set your tree diagram up however you want. I like to use the first option they give me, which is 3 math classes. So I've got Math 1, Math 2, and Math 3. And then over here, I'm going to come down and write science. All right, and I have 2 science courses. So I've got Science 1, Science 2, Science 1, Science 2, Science 1, Science 2. All right, and here's our tree forming. So I'm going to go and I can pick Science 1 or Science 2 depending on which math class I choose. All right. And then on top of those science classes, we have 2 humanitarian classes. So I'm going to go down here and we'll call this humanitarian, but I'm going to abbreviate to human. And we've got a humanitarian 1 and a humanitarian 2. And let me scoot that over a little bit. And H1, H2. And H1, H2, H1, and H2. And we'll just do like we did up top, and we will draw our lines into each of the classes that are available. All right, and if you notice, there are 2 science, and 2 humanitarians. We can simply multiply these together. 3 times 2 is 6, 6 times 2 is 12. So we have 12 different choices. And if we look at the very bottom of our tree diagram, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different classes. So that's how we do our tree diagram. Now, sometimes the data becomes too much and we don't want to use a tree diagram. So what we'll do is we'll get into making easier calculations. All right, but first we need to understand a few things. And any independent event doesn't affect each other. A dependent event, they do affect each other. So an example of a dependent event could be like a race, who comes in first, second, or third. Okay. All right, and the basic counting principle, I'll let you kind of read that. And P times Q ways, that's kind of what we did up here at the top. We multiplied our 3 different options together with the number of choices. All right, so let's go to example 1, and I'll pause for a minute so you can read the choices, or just hit pause on the video notes and you can read this question, all right? And after you're done reading it, they have a couple of questions we need to answer. Are the choices for each book independent or dependent events? These are independent events because the choice of one book can change. So the first spot right here, the first spot can be any one of these, okay? And it could be a nonfiction, it could be a science fiction, history, or romance. And on top of that, say you put the first spot as nonfiction, but you want to flip-flop it, okay? You can flip-flop and put science fiction first if you want to have that in the first spot. And then nonfiction would go to the second spot. So that's what makes those independent, all right? Now, how many different ways can Vicky choose the books? All right, this would be a lot for a tree diagram. So there's some easier ways to calculate that. And what we did up top was we took 4 times 4 times 3 times 3 times another 3. All right, and we end up with 432 different choices. That's too much for a tree diagram. Okay, too much for a tree. So that's why we need to learn how to multiply out our choices, and it makes it a lot simpler. All right. Okay, moving forward, factorials. Factorials might have been something you saw back at the end of Algebra 1 or in geometry, or at the beginning of Algebra 2. And a factorial takes a number. Okay, so so for example, I'm going to say 7 factorial. All right, so you just have to expand that in sequence. So 7 factorial is multiplication. And we got 1. We're going to count up to 7. 1, 2, 3, 4, 5, 6, 7. And we're going to put multiplication signs in the middle of everything. Okay? And in your calculator, you would just type in 1 times 2 times 3 times 4 times 5 times 6 times 7. And you would get 5040. 5040. And that is how you do your factorials. Because if you notice in your permutations, which we'll cover here in a second, all your permutations, the way we get our solutions is they have factorials in them. All right, so we'll go over how to solve these factorials. All right, and due to timing for this video, I'm only allowed to record a certain amount of time. I've already answered question A. And so what I would do is just pause and read the example, and I'll cover the examples right here. So are the selection of first, second, and third place from the 3 horses independent or dependent? They are dependent. Because once a horse is in first place, it stays. Okay, unlike the books where we could kind of flip-flop first choice and second choice, once a horse wins first place, it stays in first place. Okay? That horse can't be moved to second or third place because it stays, it's locked into first place. Okay? All right, part B. Assuming there are no ties and the 3 favorites finish in the top 3, how many ways can the third horse win first, second, and third? This is where we're going to use our permutation of P in comma N. All right, and all that means is I need a factorial. All right, so my factorial for this is going to be looking at how many places there are. There is first, second, and third. So that means that n equals 3. So I'm going to take this factorial and I'm going to say 3 factorial is how I find out, all right, how many different ways. And that 3 factorial is going to turn into, let's put out 1, 2, 3. And put your multiplication in there. 1 times 2 times 3 is going to give you 6. So our final answer for B is 6. All right, moving forward. How many different ways can all members sit at the conference table as shown? Okay, so we have member 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That means n is going to be 10. All right, so for part A, all I need to do is use my first permutation of P in comma N. And we know that that is n factorial. Okay, so I have n now. So for A is going to be 10 factorial. And in your calculator, just type it all out. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Make sure you put multiplication in between everything. All right, and n equals, pretty big number, 3,628,800. Pretty big number. That's why we don't always use our tree diagrams. You'd be spending all week trying to compose a tree diagram of 3 million different options. Okay. Now for the last example in our notes, for example B, I'm going to scroll up here and we're going to be looking at this one for example B. Okay. And that is P of NR. So we've got P in R. Okay, so I need to find out what R is. And what I'll do is I'll go in here and I'm going to count the options in here. How many ways can they elect a chairperson? That's 1. A vice chairperson, that's 2. A treasurer, that's 3. And secretary, that's 4. So I've got 4. And I'm going to plug it in. And P comma NR is going to give us this equation of n factorial over n minus r and then a factorial. All right, so let's plug in what we got. So I'm going to change this equation. Let's change colors here to n, which is 10 factorial over n minus r, which is 10 minus 4. Then I got a factorial on the outside. All right. Okay, so let's go ahead and simplify what we can. 10 factorial is going to change eventually, but we got to solve what's in the parentheses first. So I've got 10 factorial over 6 factorial. Okay, because 10 minus 4 is 6. So we already know that 10 factorial is 3,628,800. All right, and in your calculator, you'll just have to type out 6 factorial, which is just 1 times 2 times 3 times 4 times 5 times 6 is 720. Okay, and once you do the division, you end up with 5040. Okay. Now your assignment will be more straight up calculations. You won't really have to read into these word problems. All right. And you will have to do a tree diagram. All right. So if you have any questions, please feel free to email or message me.